Question number 3 from our friction worksheet that we had due for today says a 100 kilogram object moving at 20 meters per second comes to a stop over a distance of 40 meters. We want to know the coefficient of dynamic or kinetic friction acting between the object and the ground. This is clearly kinetic friction, not static friction. Static friction is acting on an object that's not moving. This is moving. It's slowing down and stopping, but it's moving right now. Okay, what's another word for sliding friction or dynamic friction? Sorry. What's another word for kinetic friction or dynamic friction? Sliding friction, right. This object is sliding, right? It comes to a stop. It's sliding along the ground. This is kinetic friction. So if we want to find that coefficient of kinetic friction, the only way we're going to do that is to use the kinetic friction equation. F is equal to mu times the normal force, which normal force is, so far, it's always going to be what, Patrick? Mass times gravity, right. So we're going to change that equation to look like this. FKF is equal to mu times m times g. Now, we don't know what the force of friction is. Okay, if we want to find mu, we need every other variable in that equation. We know what m is, we know what g is, but we don't know what F is. Any ideas? How are we going to find this value of F some other way? What's the only other equation we have to solve for force? Somebody said it? I heard it out there. F is equal to m times a. Yeah, Newton's second law. Now, how can we say that these two forces are the same forces? Well, look, F equals ma is the net force, the unbalanced force. There's only one force acting on it. It's friction. So that net force is due to only one force, friction. Therefore, that net force is the force of friction. So let's get that. Oh, but I don't know what A is. So let's find A now. To find A, I'm going to say VF squared is equal to VI squared plus 2AD. Solve for A here. VF squared, what do we need to get rid of first here? The 2D or the VI? VI, right? It's not attached. You can take it over by subtracting. VF squared minus VI squared equals 2AD. Let's solve for A. Let's say VF squared minus VI squared over 2 times D equals A. All right, sub our numbers in here and get acceleration. VF squared comes to a stop. 0 squared minus 20 squared over 2 times the displacement, which is 40 meters. That gives me an acceleration here, question number 3, of negative 5.0 meters per second squared. Should it be negative? Of course it should. It's slowing down, right? Something's slowing down, it decelerates, negative acceleration. So the force here is going to be that mass, which is 100 kilograms, times that acceleration, which gives me a force of negative 500 newtons. Now, what do you notice in that force of friction equation? F is equal to mu times m times g. Those two vertical lines mean what? Absolute value. So what am I going to do with this negative 500, Josh? Turn it into a positive. Good. Okay, so let's just say that this is solving for mu. Take the mg over by dividing. I get FKF over m times g. I get 500. I want the magnitude of the force of friction there. Only the magnitude, 500 as Josh said, divided by the mass, which is 100 times 9.81. When I do that math, I end up getting a coefficient of friction of 0.51. How many people got that? Okay, good. Look, there's a lot to this question. This is not a trivial question. This is a hard question for you guys at this point in Physics 20. Okay, there's 3 equations that we had to use here. The force of friction equation, we had to rearrange it, of course. F is equal to m times a, and then VF squared is equal to VI squared plus 2AD. Okay, the questions are getting more complex now. But remember what we said when we were working on those Group B problems earlier on this year when we were only using one equation. Okay, if you're trying something and it's not working, then try something else. Remember what else we said? If you happen to get something you're not looking for, that's okay. Okay, either use it or try something else. Okay? I didn't get anything when I tried this, so I moved on to this. Didn't get anything, so I moved on to this. Oh, I got an acceleration. That helped me with my force, which helped me with my kinetic friction. Okay? Keep trying things, and sooner or later, it should work out for you. That is, unless you try something like V equals D over T. Why do you not want to try that one? Why do you not want to try V equals delta D over delta T? It's the wrong group. That's a group A problem, a group A equation, right? And this is clearly a group B problem because the object is slowing down. Does that make sense? Okay, again, look at, we talked about this before. Every once in a while I bring this up. Day one of Physics 20, remember where we were. Okay, remember what kind of things we were doing. And remember the kind of things you were struggling with a little bit. Okay, when I said, okay, I walk 3 meters this way, and then I turn around and walk 1 meter this way, what's my distance traveled, what's my displacement? Okay, that's what you were struggling with on the first day of class. And look at what's hard for us now. This is a hard question. But look at this complexity-wise compared to what we were doing at the beginning of class. Okay? Okay, some of you found the stuff at the first day of class hard. Okay? Some of you find this hard now. Okay? It gets better. With practice, it gets better, okay, as we're getting smarter. Okay, I want to do question number 4 with you right now. How many people had a chance to tackle question number 4? It wasn't homework. Okay, how many people had a chance to tackle it? Okay, what'd you end up getting? Okay. What'd you end up getting? 1.2 times 10 to the negative 1 or 0.12. Anybody else get that? Sean did? Okay, that is correct. That is correct. This is a tough question. Just like number 3 was. Probably even a little tougher. Number 4 says a hockey puck is hit on a frozen lake and starts moving with a velocity of 12 meters per second. 5 seconds later, the puck is 6 meters per second. So, look, initially this puck is moving at 12, and then it's moving at 6. We want to find the coefficient of friction between the puck and the ice. So let's write down some givens here. We're going to say VI. VI is 12.0 meters per second. We're going to say that VF is 6.0 meters per second, and my time interval here is 5.0 seconds. I think that's all we got, isn't it? Yeah, I think that's all we got. We want to find the coefficient. What kind of friction is it, static or kinetic? It's kinetic. This puck is this puck at rest on the ice? No, it's sliding. Kinetic friction, dynamic friction, sliding friction. We're looking for the coefficient of kinetic friction. All right, to solve for the coefficient of kinetic friction, we would say mu times the normal force, and the normal force is m times g, right? There's going to be, over the next few days, times when the normal force isn't m times g, but I'll point that out when that happens. Okay, for now, it's always m times g. Okay, we want to solve for mu. So we're going to say mu is equal to force of kinetic friction over m times g. Okay, we got a problem here. We got a big problem, it seems like at least. We want to solve for mu. Okay, so we don't know what that is. We also don't know what force of friction is, and we also don't know what m is. All right, I think that's a problem. Listen, you know what the difference is between, there's a lot of differences actually between you and me right now, okay? But one of them is not that I am so much smarter than you. Okay? In some cases, hey, some of you guys might be given on equal playing terms when you compare apples to apples as smart as I am. Some of you guys may be smarter. Right now, you can't do as much as I can do because I've learned a lot more than you guys over the years. But that doesn't mean you're not smart. Okay? That doesn't mean that you can't do something that I can do because you're not as smart as I am. The biggest difference, the two differences between you and me is, A, I know more because I'm older and I've learned more, and you can be there at some point too. And the second thing is, and this is probably the most important thing, is I'm not afraid of anything when I see a question like this. Okay, we get something where we got 3 unknowns, so what? I don't worry about that. I I look at it and say, I'll figure it out. So what am I going to do? What am I going to do to figure it out? Well, look, in the last question, we didn't know what F is, so we said m times A, right? Agree? But we don't even know what A is here. So say delta V over delta T. Okay, I'm not quite there, right? I'm not quite there, but it's coming. I can find A. Delta V over delta T is, what, 6 minus 12 over 5. That gives me, I think, negative 1.2 meters per second squared. Is that right? Yeah, okay. Hey, there's something. It's not my answer, but it's something, isn't it? So let's now say, m times 1.2. Oh, wait, I don't know what m is. This next thing that I'm going to do, this takes some real thought. Okay, and a lot of times the only way you're going to get something like this is, you've had experience doing something like this. Okay, so if you didn't get this next step, I get that. I completely get that. Everybody could have gone this far if they had tried real hard. The next step, you got to be really on top of your game in order to get this next step, especially right now. Okay, here's what I did for the next step. I said mu k is equal to, look, it's m times A, right? In other words, mu k is m times 1.2. I don't know what m is, so let's just say it's m times 1.2. Positive because absolute value, right? What's G? 9.81. Look what just happened. Look what just happened. Or look what's just about to happen, I should say. What's about to happen here now? Cancel the m's, right? So I'm just going to say mu is equal to 1.2 over 9.81. That gives me a value of 0.12, and that's my answer. So everybody in this room can get this. Everybody in this room can recognize that force is m times A. Everybody in this room can recognize that we can get the acceleration by delta V over delta T. We're all capable of that, all of us. Okay, then to sub in m times 1.2 right here, okay, that's a bit of a stretch sometimes. Okay, if you got that, fantastic. If you didn't, that's okay. Hey, now you've seen it once. Now if you ever have to do that again, you're a little bit better equipped to handle that. Sometimes that happens to us. Hey, if we're looking for something and we end up having a couple unknowns, sometimes instead of subbing in a number for a variable, maybe we should just sub in an equation for a variable and see what happens. Because sometimes we get some canceling going on that makes life a little bit easier for us. Another example here. We got to copy this one down because it's not in our textbook. It says a 10-kilogram object at rest on a surface that has a coefficient of static friction of 0.95 and a coefficient of dynamic or kinetic friction of 0.65. What is the value of the force of friction if we apply 50 newtons to it and if we apply 300 newtons to it? What kind of friction are we dealing with here, static or kinetic? Who thinks we get static friction here? Okay, I see a hand up, a couple hands up. Who thinks we have kinetic friction? Couple hands, sorry. 50-50, 2-2. I'll tell you what, I don't know right now what we got. I don't know whether we got static or kinetic friction. I'm going to be a fence sitter. I'm going to say, I don't know whether it's static or kinetic friction. I push on it with 50 newtons, does it move? I don't know. 300 newtons, does it move? I don't know. How do you know, how do you figure out if 50 newtons is big enough to cause this to move, and therefore whether or not we have kinetic friction or static friction? How do you figure out if 50 newtons is big enough to make it move? Yep. Okay, let's do that then. Let's get the maximum force of static friction. FSF max. Okay, remember, this is not the force of friction that we're finding. This is the maximum possible force of static friction. Remember the other day when we introduced this, we kept pushing Jacob's desk? We said the maximum force of static friction on Jacob's desk was 100 newtons. That wasn't the force of friction. That was just the maximum that that stubborn frictional force could push back with. Okay, that's what we want to find right now. And that's equal to mu times Fn, which of course, Fn, Georgia, Fn, the normal force, is equal to what? Mass times gravity. Good. So we're going to say mu s times mg. Mu s is 0.95 times m, which is 10, times 9.81. That gives us 93.195 newtons. Now, I'm not going to round that. How come? I'm not going to round that to 2 digits. I'm just going to leave that as 5 digits because, good, it's not a final answer. Okay, I didn't solve for anything here yet that I'm looking for. I just need that number to compare these other numbers to it. All right, if the maximum force of static friction is 93 newtons, and I apply a force of 50, does it move? Does it move, Rachel S? No, it doesn't. Okay, so what kind of friction do I have if it's not moving? Sure, static friction, right. So in question A, when I push on it with 50 newtons, I've got static friction. And what's the value of static friction? What's its value? Stubborn friction, static friction. It pushes just as hard as it needs to. I push with 50, it pushes with 50. The only reason I calculated FSF max is to see if, when I push on it with 50 and 300, to see if I exceed that value. If I do, then I've got kinetic. If I don't, then static friction is easy if I don't exceed that maximum value. Because if I push on it with a certain value and I don't exceed static friction, then the maximum static friction, then the force of static friction will simply be the value that I push with, 50 newtons. Okay, if I push with 300 newtons, does it move? Does it move now? Yes, it does. Good. So this is kinetic friction then, right? What's the value of kinetic friction? Do we know that? Yeah, we got to find it, right? It moves. Kinetic friction. Let's find kinetic friction force. It's mu times Fn, which is mu times, Georgia, Fn is equal to what? Mass times gravity. Good. Mu is 0.65 times 10 times 9.81. We multiply those three numbers together. And we end up getting 63.765, or we're going to round that to 2 digits, or 64 newtons. Didn't I say, look at what we got for static, 50. Kinetic is 64. Didn't I say that static is greater than kinetic? No, I didn't say that. What did I say? Not quite, no. Getting there. Good. The maximum static friction is greater than kinetic. Okay, that doesn't mean that static friction is always greater than kinetic. The maximum static is bigger than kinetic. You ever try to push, like you're in your room and you're trying to rearrange your room and you got that dresser over there that you want to push to this wall, and you're too lazy to take out the clothes and drawers out of the dresser when you go to move it, like I am when I'm trying to move a dresser. Okay? I'm just as lazy as you guys are when I do that. You go to push it, and it's like it doesn't want to move, it doesn't want to move, it doesn't want to move, and then finally it starts moving and it's easier. Once it's moving, it's easier to keep moving. Why? Well, because the force of kinetic friction acting on it once it's moving is less than the maximum static friction was to get it moving. That doesn't mean kinetic friction is smaller than static friction always. It's just smaller than the maximum static friction that it took to get it moving. Hey, what if I added a question C to this? What if I said if 500 newtons was applied, would it move? Yes, because I exceed 93.195. What's the force of kinetic friction then? 64. What if I applied a force of 10,000 newtons? Would it move? Yes. Kinetic friction then, right? What's the force of kinetic friction acting on it if I applied a force of 10,000 newtons? 64. What if I applied a force of 91 newtons? Would it move? No. So it's static friction. What would the force of static friction be? 91. Right? It's how hard I push, as long as I don't push above the maximum force. Okay, make sense? So you see a question like this, first thing you got to do is calculate the max force of static friction. If you don't exceed that value, then static friction will simply be however hard you push the applied force. If you do, then you've got to calculate kinetic friction, and then it's not going to matter how hard you push, as long as you're above that maximum force of static friction. Okay, does that make sense? What I'd like you to do right now then is take a look at question number 5 on your worksheet that we were working on just a little while ago here. Question number 5. Please. All right, let's do number 5. It says a 100 kilogram object is at rest on a horizontal surface. The coefficient of static friction between the object and the surface is 0.6, while dynamic or kinetic friction is 0.45. We apply a force of 400 newtons for 5 seconds. What's the force of friction? Hey, what relevance is the time here? 0. No relevance whatsoever. If 400 newtons is enough to move this object, then 400 newtons will move this object in 1 second or less. We don't need 5 seconds or 10 seconds or 5 minutes to move this object. If it's going to move, it's going to move. So the time is irrelevant. The time doesn't matter at all. What we want to do to see if 400 newtons moves it or not is get the maximum force of static friction. In a question like this, that's what we always do. Get the maximum force of static friction first. So let's do that. It's mu times Fn. It's mu s times, what's the normal force here, Georgia? Mass times gravity, good. So we're going to say it is, 0.60 times 100 times 9.81. We multiply all those together, and we end up getting 588.6. That's my maximum force of static friction. That's not my answer to A. Okay, that's just the number that I have to calculate to get the answer to A. This is the force that I can push with that begins to cause it to move, or causes it to begin to move. If I apply a force of 400 newtons, does it move? No, because I haven't exceeded that stubborn force, right? It does what it needs to do. Remember, if I apply a force of 100, it pushes with 100. I apply a force of 587, it pushes with 587. I push with 590, it stops acting. But if I push with 400, it pushes with 400. So the force of friction here will be static. It doesn't move. And the value of the force of static friction, not FSF max, but just FSF, force of static friction, is simply equal to 400 newtons. Because it's less than the maximum value. I push with less than the maximum value. All right, B. Force of 650, 5 seconds, again, doesn't matter. If I apply a force of 650, does it move? Yes. If I apply a force of 650 for 5 seconds or 0.1 seconds, it moves. So what kind of friction do I have? Kinetic. So Ben, what do I got to do here now? Well, there is no max kinetic. Kinetic is just kinetic. So let's get the force of kinetic friction, not FKF max, just FKF. But multiply mu times the normal force, and of course we know the normal force is m times g. So we're going to say mu, which is for kinetic friction is 0.45 times the mass of 100 times 9.81. That gives me a value of 4.4 times 10 to the 2 newtons. There's kinetic friction. Hey, what if I applied a force of 900 newtons? Would it move? Yeah? So it's kinetic then, right? Benton, how much kinetic friction would it be if I pushed with 900 newtons? No. Static friction would be, you're saying 0 now? Static friction would be 0 because it's moving. Kinetic friction would be 4.4 times 10 to the 2. If I apply a force of 20 million newtons, moves, right? What's the force of kinetic friction if I apply a force of 20 million newtons? 4.4 times 10 to the 2. Benton, once it's moving, the force of kinetic friction, it's not a stubborn force. Okay? Static friction is stubborn. It does, like, however hard I push, it pushes back with the same force, okay, until the maximum value. But kinetic friction doesn't. Okay? Whatever the value of kinetic friction is, doesn't matter how hard I push, as long as it's moving, that's the force of kinetic friction. All right? Okay, what's the answer to C, everyone? How much force is required for the object to start moving? 588.6. We'll say 5.9 times 10 to the 2 newtons, or 588.6. Hey, why did I round that this time? Because the final answer now, right? When I calculated it initially, it wasn't a final answer. It was just a number that I was going to use. But now it is a final answer. Yeah? Patrick? Answers your own question? Good. Okay. Take a couple minutes here, guys, and answer questions 6 and 7 for me, please. Okay? Write down, let's say, there's one situation for each low and high for static and dynamic, or static and kinetic. So see what you can do with questions 6 and 7 right now at your desks, please. All right, question number 6.
Good afternoon, staff and students. It is time for our